Okay, so we're going to get into our first kind of chapter here. So this is all about LAN design and general network kind of network design. So this is a little bit of the older CCNA version, but I think it's still kind of important that we go over it because they did trim out a good chunk of the old CCNA material, and I kind of think that we've got some good stuff that we can go through still. So um, the idea of kind of this initial chapter is to go over kind of campus wire designs, how we can kind of scale and design a network, specifically looking at, say, like medium-sized businesses. So getting into kind of our general LAN topology, we need to think about when we're scaling and building out a network. So the first thing that you typically want to focus on and kind of think about is what your enterprise network needs to be able to do. And so the primary kind of ideas is needs to be able to exchange, various types of network traffic. So it needs to be like, say, like TCP/IP. We need to be able to send out video messages, VoIP. All these different types of messages need to be able to go through. We might be implementing different forms of data transfer as well, so wireless networks are likely going to be built into our organization as well. So there's lots of different kind of components that have to be designed and organized for our network. We have to be able to support critical applications. When we talk about critical applications, we're discussing your business critical applications. So these are the things that have to be running in order for your organization to actually work. Has to support converged network traffic as well. So again, that kind of ties back to our first item where we're talking about the various types of network data. Support diverse business needs. Everyone has something that they need to be able to do. So if you look at, say, like some different types of companies, like an oil and gas company, they're likely going to need to be able to do, say, a lot of data related to actual oil and pipeline designs. So that could be, say, like laser scans of a specific pipeline design, could be information related to project design plans. So there's lots of different ideas, but then there's also payroll that has to be paid out. There's people working on databases on back end. So there's a lot of different things that typically happen. So we have to think about how are we going to design the LAN, especially now in current times where everyone's kind of working from home. How are we going to structure everything to be able to work from home? So if you have an organization that's 3, 4, 500 people, how are you going to get them all working efficiently and effectively from a home environment, and also securely too? So there's a lot of factors that we have to kind of think in and kind of look at. And then of course, the one thing that I forgot to mention, it's probably the most important thing, is we have to factor in backups as well. So it's not just backups for the internal network and LAN, but we also have to think of, you have the internet out there. We likely are going to be storing stuff on the cloud now. So how do we do potentially backups on the cloud? So that's another important thing to think about as well. If I've got 150 terabytes worth of data and I have a 1 gig connection out of my business out to my ISP, and I'm trying to initially put that 150 terabytes out onto, say, like a cloud backup, that's like a 2-week minimum project, just sitting there twiddling your thumbs watching data transfer. And you can't do that during normal times and business times too, so you gotta think about that. So other things that we kind of look at, one thing that Cisco really likes to push forward is what's known as the Cisco hierarchical design model. Now this is actually a pretty decent model. So it's designed into 3 methods here. or 3 layers, and there's also another version of this which is known as the collapsed core method as well, which is a 2-layer design. So for the 3-layer design, we have 3 primary areas. We have the access layer, which is the very base layer. What we know at the access layer is just for that. It's for our end devices to be able to access the LAN. So these are your wireless routers. These are your immediate switches or ports that people are plugging into. That's your access layer. So these are your access layer is typically comprised of layer 2 devices. Then we have our higher up layer, which is our middle layer, which is known as the distribution layer. This is typically where you're going to see a lot of layer 3 switches. And that little sun design, where you have multiple arrows coming out of a circle, that typically is a design to show you that this is a layer 3 switch. That's typically where most of your access layers are going to meet into that centralized location. And then it will then move up to the core layer, and the core layer is where you see a lot of this is where your primary network structure is kind of set up. So these are your primary switches, your core switches that will typically allow data transfer out, going out towards, say, like the actual internet, or where you might have, say, like other connections out towards, say, like your backups. This is the primary location that you have. So when we look at, say, like Whatcom Community College, the way we kind of think about this, if we were actually in the building and stuff, is that if we were in a lab room sitting in front of the actual computers there, our PCs that are sitting there have a wire that runs out to a closet that has a layer 2 switch in there. That would be an example of our access layer. That access layer then, from that closet, we have fiber that runs all the way over to another building, which goes to the primary distribution layer, which is where IT is kind of centered. And then from that distribution layer where those layer 3 switches are, they run all the way out to another kind of room in the back, kind of a back alley area, which is basically a fiber closet. So it's a bunch of core layer 3 switches designed strictly for fiber. They're very pricey, but they're good to use. And then we have multiple fiber connections out to our ISPs from that area. So that's the primary aspect. You'll typically see this designed for medium-sized or larger organizations is typically what they utilize. For smaller businesses, you'll probably see more of what's known as a collapsed core design, where we're combining the core layer and the distribution layer together. And that's the primary kind of thing that you'll see. So essentially it's a collapsed core design between the two. So core and distribution do the same thing. Oops. So when we're originally developing a network, the biggest thing, there's 2 primary things you want to kind of think about. One of the biggest ones, though, is absolutely scalability. And what we talk about when we're thinking about scalability is not just how big the network we can make it, it's also thinking about being able to incorporate redundancy, increasing throughput in certain areas, being able to add on in a modular fashion into our network as well, and then being able to design a larger scale network if we're using, say, a routing protocol like OSPF. We've used it for our normal single area. We could break that up into a larger network and utilize what's known as multi-area OSPF. So there's lots of different options to kind of think about. Other things that we have to kind of think about too, and from a scalability side of things, is do we need to address IPv4 and IPv6? Which side are we going to kind of lean towards? Odds are we're probably going to pick IPv4, but IPv6 is becoming more and more prevalent. And in fact, most internet service providers, typically, if you go out and purchase an IP address, they may or may not have IPv4 addresses available anymore. They typically do for most businesses, but that's something that you kind of have to factor in. So other things that you have to look at too is, what types of devices are we going to purchase as well. So it's kind of typically a good idea to go for, say, like modular equipment if possible. It allows things to be a little bit more expandable, so you don't have to worry about running out of space. So if I buy just a 24 port switch, but I'm not planning for expansion, that can come back and bite me. But then if I buy a wrong switch, if I'm like, well, I need to have multiple 10 gig ports on this switch, but I'm probably not going to use all of them, and I need more than that, and those switches are expensive, so maybe I'll just go with a 48 port switch that are all 1 gig ports, but then only one of the primary ports has a 10 gig link. That can be a problem too. It can cause potential bottlenecks. And then you also have to factor in all these other things of like, okay, well, can they support either channel? What can they do? Can I configure redundant links? So that's a lot of issues. Now, building a network is very important, but odds are for most organizations you're likely never going to actually build a network from scratch, more times than not. You typically will walk into an actual organization and then have to just fix or work with whatever you have. So is what it is. So again, plan for redundancy for a lot of your networks, a lot of your network design. Redundant paths are absolutely very, very important when you're dealing and setting up a network. Now, how many redundant paths? Cisco's like, hey, at least a couple as we go through it. It's kind of a make or break. If you can do it, great. If you can't, try and do it in the future. It's not going to be the end of the world, but you should absolutely try and do it. Now, depending on how you're implementing your redundant links, especially on your layer 2 devices, make sure that you're setting up STP, so spanning tree protocol, in order to prevent switching loops from occurring, because broadcast storms will absolutely cripple your network, so don't do that. So failure domains. Failure domains just are essentially just determine if one device goes down, how much of my network is actually impacted, which area kind of goes through. So we can see along the lines, if we're looking down at the bottom here, if switch 2 goes down, H4 obviously goes down, but also S3, H5, and H6 all go down. So that's a whole failure domain right there if those devices actually go down. So when we're talking about failure domains, they basically are just trying to say, make them as small as possible, and you can do that by adding in redundant links as much as possible. So moving on, another thing that we can do if possible is increasing our bandwidth. Now, this slide's kind of a lie. We can't increase our bandwidth. We can increase our throughput. You can't increase your bandwidth unless you buy new hardware or buy new modular stuff. So our ports that we have, whatever we purchased at the time, if I bought a 24 port switch and they're all 1 gig ports, those ports will never be able to go more than 1 gig. So if we look at, say, like Microsoft Whiteboard. Let's clear our canvas. You know, if I've got two switches here, and I've created a bundle, so an ether channel between the two sides, you know, if these are 1 gig ports for all of these sizes, all of these ports are 1 gig. At max, what this is doing, what ether channel is doing, is it's not increasing my bandwidth. My bandwidth is still equal to 1 gig. It will never go more than 1 gig. However, by bundling these interfaces together, my throughput has just increased to 2 gigs. So the amount of traffic that I can actually handle between these two has now doubled. So throughput is different than bandwidth. Bandwidth is the theoretical maximum speed that my ports can actually go. Throughput is what I'm actually getting. So bandwidth, you can never go faster than your port. Just can't. Throughput just determines how fast I can actually send, how much data can actually be processed between the two sides. So that's an important thing to kind of note between areas. So expanding the access layer, again, things we can do, we can look at adding wireless access points. That works. So we can also look at, when we're talking about expanding our network, we can look at, you know, what they're calling fine-tuning routing protocols. So this is looking at, say, like OSPF, where we can create what's known, most things that we use when we set up OSPF are what's known as single area OSPF, and that utilizes our backbone area of just area 0. But we can also create what's known as multi-area OSPF, where as long as we have multiple areas that are touching a backbone area of area 0, I can actually fine-tune OSPF to limit the amount of broadcast messages that are actually being sent back and forth. So that's kind of cool. Or not broadcast, but it's multicast messages, and they're routing update messages between it. I'm going to go all super in-depth into OSPF later, but that kind of just gives you a general idea. Another protocol we can use besides OSPF is EIGRP, but it's Cisco proprietary, so unless you're a Cisco shop, you're likely, if you're picking a routing protocol, it's likely OSPF. So not going to go too in-depth into this side of things, kind of going to wrap it up here in a minute, but the general idea is, what type of switch do you want to use? There's lots of different switches that are out there. You can grab these big honking ones. They work. They're modular switches, which is pretty cool, except they're super expensive. These, when I was talking about core switches, these are typically core switches. This is what you'll see in big networking environments. You'll typically have a bunch of Ethernet ports, a bunch of fiber cables as well, fiber ports. So they're great. They're also crazy expensive. So you're typically not going to see them unless you're working in, say, like a data center or cloud service area. These smaller ones down on the front row here, this is what we actually see. I have a couple of them in our lab environment. They're neat. So pretty much all same stuff. Now, one thing that we will kind of talk briefly about here is power over Ethernet. Power over Ethernet is very important. If you have a switch that's going to be running at the access layer, and you have, say, like Cisco phones or other forms of like VoIP phones, you need to make sure that your switches that you're purchasing have the PoE capability built into it. So PoE just standing for Power over Ethernet. If they don't, you just wasted a bunch of money. So make sure that, you know, if your devices need to do it, they can do it. What Power over Ethernet does is it allows a specific device to actually receive power directly from the Ethernet cable, as opposed to having its own, say like AC battery or AC adapter plugged in to, say, like a wall outlet. Same thing, not just with the phones, but if you have access points, PoE is thumbs up. That's very good. Use it. It's basically what we're gonna go over. Kind of gonna leave it at that for a general sense of things. If you have questions as we kind of go through it, you know, feel free to reach out. Yeah. Otherwise, hopefully that was informative. We'll get more in depth into it. I'll have an OSPF video out soon as well.